Hi guys, welcome to Quick Revision Part 2. This one is about the financial accounting systems. So I hope you've already covered Chapter 1 with all the comfort needed. Now let's move on to discussing Chapter 2. This is a fairly simple chapter compared to Chapter 1. Here some basic details are there. So let's go about dealing with the first part. In this particular chapter, what we are going to deal is the definitions. Obviously the first two definitions that you see here will be what is a system and what is a process. We need to clearly understand what exactly will be a system and what is a process. A system is nothing but a set of principles. A set of principles or procedures when normally they are performed together. When a set of activities or a series of activities which all work together to accomplish a common purpose or a goal, that is also called as a system. In an organized scheme or methods, when a sequence steps involved in doing things, that is only called a system, or you can also have better definition saying small components working together, small components working together to achieve a common purpose, That's what the entire story is about when it comes to what is a system. Then let's move on here, trying to understand what exactly constitute the term process. Now you know this because we already discussed automated business process. Process is a sequence or a series of steps involved. Process is nothing but a sequence or series of steps involved in dealing with some of the things. So when you define a particular way of happening, that is only called as a process. Process is a defined sequence. And as I told you, you must have the practice of making short notes so that things become more easy later. So process is defined as a sequence of events that uses inputs to produce outputs. So you know this, what is a system and what is a process. Like I told you in the first video, we will discuss once again the concept of master data and non-master data. Things are going to be more easier here. So what is the concept of master data? Master data, as I told you, relatively permanent data that doesn't change very often. Master data is what? Relatively permanent data which is not expected to change again and again. It's not expected to change again and again. And when you talk about this one, transaction data, which is the non-master data, now that is going to change transaction after transaction and area after area. Non-master data is the data which is expected to change frequently. So here it is master data which does not change very frequently, while non-master data which changes frequently again and again, but not a permanent data. Amounts recorded in each transaction, that's the best example of a transaction data because amounts vary from transaction to transaction. The amounts do vary, so which is why amounts recorded in each transaction shall be different every time and they are expected to change again and again, which is why they are called as transaction data. Data recorded in each transaction is expected to change again and again. Okay, so very simple. What is system? What is a process? What is master data and non-master data? And the next question is, why should we have master data and non-master data? I think this could possibly be a question in the exam, so concentrate on this bit. Master data is generally not typed by the user. Master data is what data? Something that's not typed by the user. It's chosen from a drop down. Okay, it's chosen from a drop down generally. So master data is generally not typed by the user. It is selected from the available list. Like say for example, list of debit ledgers. Which ledger you want to debit, you will always find it in the list of ledgers and you will say select that. Master data is usually done less frequently. Master data entry is done less frequently, maybe once in a year. When a new employee joins up, then again they set up the master data for him. So all these are some of the points that we need to take into consideration. Master data is usually less frequently, so maybe once in a year or when there is a need to update. Effective controls over master data entry. Effective controls over master data entry will be a 4-eye check. That means at least 2 people. You remember segregation of duties? So whenever master data, we talked about master risk in the first chapter. So whenever there is a master data being entered, We need to have a 4i check, segregation of duties. The same person who is having an authority to enter the transaction data should not have the authority to enter master data, because if that guy is also doing the transaction, he may perpetrate a fraud. So you got to be really careful about that and see who is the right person who is given this power. Whereas effective controls over master data would be a 4i check, where there is always one person independently who checks whether the master data entry is accurately done in the financial system of the company or not. Non-master data, sometimes non-master data can be entered from drop down, but generally non-master data is typed by the user, amount, okay, quantity, all these are non-master data and not selected from the available list, and it is not permanent and it keeps on changing again and again. Some transaction data, sometimes, not always, but some transactions data can be selected, like say for example POs, outstanding purchase orders are there. Let's say PO 0045 is still outstanding, and against this you received goods. So when you receive goods, you will mark a GRN. Let's say GRN number 15, GRN 015. So then GRN 015 is against which PO? Though it's a transaction data, the list of open POs can be selected from a drop down here, where it will show all the open POs. So in such a case, only those POs for which goods are yet to be received will come in the drop down list, and you can select one out of that. So that is what is called master data being selected from one of the drop downs. Very rare, but non-master data being selected, but yeah, still it can be selected. Master data generally is always selected from drop downs. So that was the example that is given there. So what is a system, what is a process, what is master data and non-master data? We have clearly discussed all this. Then let's go to the next topic, which is again a favorite topic of the examiners. It's already appeared in the exam one. So let us have a quick understanding of this particular topic here, wherein we are going to discuss about working of a software. That how is a software going to work? How is the software going to work in terms of what exactly the software is? It is classified into a front end and a back end. It's classified into front end and back end. Front end is that part of the overall software. Front end is that part of the overall software which actually interacts with the user who is using the software. Backend is now something that does not directly interact with the software, because it just interacts with the front end. Now I as a user will talk to the front end will talk to the back end and get me whatever I'm supposed to get. That's the working of a software. Normally that's how the software is supposed to work. Let's now go ahead and talk about why. Okay, why? There are very simple examples here. See, I think you can understand the logic behind it. See, nobody can simply do both the stuff, that's front end and back end, even be it a software. So I want you to remember a shortcut here which tells you all the 5 differences. I coin it as PULSE: presentation, user experience, language, speed and expertise. We will see all the points now. First one being expertise. So they beautifully picked up an example of a restaurant to explain this concept. In a restaurant, a waiter is somebody who handles the customers, and a cook is an expert in cooking. These two jobs are separate, obviously. So you understand the difference there. Waiter is supposed to handle customers, while cook will cook the food. So is the case with front end software is meant for handling the requests from users, while back end is meant for storing and handling the data. That's how each of them are good at whatever job they do in the form of a domain expertise. And having said that, then we're talking the next thing about presentation. What about presentation? Waiter, when he comes to the customers, he can present himself more clearly and talk to the customers in a more beautiful manner, rather than the cook. Cook is somewhere working in the kitchen. He can't come and talk to the customer in a pleasing manner. Not that he can't, but respectively they have expertise in respective jobs, and also presentability is important. You can't expect a cook to directly walk away in the same uniform to meet a customer. It doesn't seem right. Waiter can present himself as well as the food in better way, and also everybody likes good presentation. One cannot expect to be a good presentable cook. So is the case with this. Front end is meant for interacting with the user and presenting information in a proper format, different colors, bold, italic, letters, tables, charts, etc. While when it comes to back end, software is not meant for it and it cannot be expected to do so. So let the software take care of all the processing activities, while the backend will take, backend will take care of all the processing activities, while display, graphic output, all that will be taken care by the front end. And not only that, user also will have a smooth user experience. Waiter handles the processed food and not raw material. The whole process of getting the desired food from ordering to billing should be smooth. That's how we expect it to be in the restaurant, right? So say is the case, this is supposed to be done by a well-trained waiter and cannot be expected from a cook. So if the user has to understand the output presented by the system, front-end software should present it in such a manner that it's easy for the user to understand. Front-end software should guide a user to the desired report or feature. Front-end software should guide a user to the desired report or feature. Front-end software handles processed data. Front-end software handles processed data and not raw data like the backend. User interface of front end needs to be intuitive. That means something that can infer, understand with the minimum help sought by the user. If the user is only doing everything, then why will we have this, right? So it should have, like I said, two more points: speed and language. After placing the order, customer wants quick delivery. Now expect same thing here. See, waiter can't take the order, then go inside, cook and bring and give you all this. That doesn't make any sense, right? So, which is exactly why we need to have two ends, front end and back end. Front end will accept the request, back end will work on the request. Things will become more faster and smoother. Using single software for both the aspects would unnecessarily increase the load, and slow down the speed. So therefore, separate backend software is used for handling data only. So this reduces the load on both of them and it is faster when it comes to doing both. Then language. Waiter needs to be polished and polite. And he or she needs to understand the language of the customer and speak to the customer in the language the customer is comfortable. Cook has nothing to do with this aspect. Now, cook doesn't maybe even not be knowing the language of the customer sitting outside and eating, but as long as he knows to cook, he's good in that, it's enough. So is the case. Front end speaks the language of the user, what is understood by him, while back end has all the technical part. So presentation should be cool, user experience should be simple, language should be smooth and understandable to the user. There should be speed and expertise in doing the work. Pulse could be a shortcut for understanding what is the working of a front end and a back end software. Let me also at this point of time discuss what constitutes to a cloud application. Let's now see that. What is a cloud application? See, nowadays more people are not interested in dealing with setting up and working on their own software. So what is the next best thing that they do is to go for a cloud based application. In this case, these days, many organizations do not want to install financial applications on their own. For many organizations, they even think that it is not their primary function. To operate complex IT systems and have a dedicated IT team and hardware. Who is having the time and patience to take all that burden on their head? So what will they do? They hire a cloud space. Thus, organizations are increasingly hosting their applications on the internet. The internet is only viewed as clouds. So there are many methods through which this can be achieved. Little later in our revisions, we will discuss about cloud computing. So, cloud-based application, a web-based application, and an installed application. Installed application needs to be put up into your system, while a cloud-based application will be, it will be available on the web and you can actually use it. Okay, so that brings us to the understanding of, I think there is a difference table for installed applications versus cloud applications. Okay, installed application versus cloud application, it's an important part of discussion. So I think you should try and figure out what are the differences between these two. Let me quickly take you through the differences as to what exactly will be brought in terms of understanding the installed application versus cloud based application. Now if you see, there are around 7 points of difference. First one, installation and maintenance. Now you have to install the software and the entire maintenance of software is on your head. So it's not a really favorite point on the installed app. It's great on the cloud app because installation and maintenance are not on our head. Then accessibility. When you talk about the accessibility, again, you have to go and work on that system where the application is installed, whereas cloud can be used anywhere 24/7 from any place. And not only that, working on mobile applications. Not that installed applications don't work on mobile application, they're pretty slow on mobile apps, but considering cloud-based applications can be used anywhere at any time on a mobile device. So these 3 points are pretty much favoring the cloud. But then coming to the next 3 points that you're going to look at here, we will talk about data storage. Okay, we talk about data storage. Then we talk about data security, and then also talking about performance. Yes, data is stored within our computer, very much within the limits of what we can use. So data storage is pretty much here. Data security, since the data is not on any third party cloud and it is with us. So when it comes to data storage and security, our installed applications are absolutely fine. And performance also is totally dependent on how you treat it, and when it is in your system it works well. So kind of 3 points favoring the installed applications, 3 points favoring the cloud, but the last one talks about flexibility. Now wherever it's flexible to use, you can always use. There is no hard and fast rule that it has to go like that only. Flexibility is a point on both sides. If installed application is flexible for you to use, you can use it that. And if you prefer using cloud applications are also scalable and reusable whenever they want. So yeah, we are not concluding which one is better or not. All I am saying is, yes, you have installed application and cloud application, that also has been covered. That is our point of consideration. Then let's get to the next part of this chapter, where we will be dealing with 2 types of systems: non-integrated systems, and then coming to integrated systems with a whole lot of discussion on what are those integrated systems, and then we will go about discussing what is called as the ERP and all that. Okay, so first let's talk about what is non-integrated system. A system that's not connected to the other systems, a system that can work on its own independently, where there are, like, say, for separately for a finance, separately for accounting, separately for HR. If you are maintaining systems, then it's called non-integrated system. It's a subsystem of maintaining data in a decentralized manner. In what manner? Decentralized manner. Each department shall maintain its own data. Each department shall maintain its own data separately and not in an integrated way. 2 problems. One, there is communication gap because we don't know what somebody maintained and what somebody not. And then there is a problem of mismatched data from one department. When it's transferred to the other, where entering of data happens, there is always a possibility of mismatch some data. Then to avoid the 2 problems in non-integrated systems, we brought in an integrated system, which is every organization uses a variety of resources in achieving these goals. ERP, the enterprise resource planning, is an enterprise wide information system. So you know what an ERP is, right? Finance, marketing, HR, all these modules are brought together, okay, under the one single software. It's absolutely maintaining data in a centralized manner. So integrated system goes by centralized data maintenance, whereas here in non-integrated it goes in decentralized manner. An ERP system has a common database and a modular software. An ERP system is based on a common database and a modular software design. The common database can allow every department, to store and retrieve information in real time in one particular place. The information should be, how should the information be? Wherein the data stored in central, reliable, accessible and easily shared. Information be reliable, accessible and easily shared. Then ERP follows a modular approach. The entire ERP is not one software. The entire ERP is broken down into several modules. What are those modules? We will be seeing very shortly. What are those modules and what are their key integration points? We will see both. In order for a software system to be considered ERP, when do you consider a software ERP? Sir, finance and accounting or finance and taxation are together. Can I consider ERP? Finance and HR are together. Can I consider ERP? I don't care what are together, but all I'm saying is if two or more are together, then that's what considers to be a ERP. In order for a software system to be considered ERP, it must provide an organization with functionality of two or more systems, maybe like say finance plus HR. If you have both, finance plus HR, if you have both, then that can only be considered as an ERP. Anything two or more, that's what an ERP is all about. Got it? A 2 stars to this particular topic here. If you don't have the module in front of you, you can always note down these points, because this is a new May 2020 introduction exclusive topic called as benefits of an ERP system. So it can always come up in the exam, but there's nothing very really serious about this. A very simple topic, 12 advantages. I can take you through that just about in a simple minute. Information integration is maintaining a common database, all at common database, that too in a centralized manner. What do you see is that it's maintained in a centralized manner. Then when you make an order, the time taken for you to wait till you receive the goods is called lead time, right? And that lead time obviously will come down. Reduction of lead time. Timely shipment will happen. On time shipments. Shipment, I mean like they are delivered to the right person in the right time. Time taken to complete one full process is called a cycle time. There's a reduction in the cycle time as well. Improved resource utilization. None of the resources will be empty right now. You remember the 5 resources, the 5 M's: men, material, money, machinery, market. All that be improved resource utilization tends to be better. Like say for example, if the dispatch team has to work, then you need an order to be placed. First the order is placed, then the procurement team will procure the necessary goods, manufacture, and then the dispatch team will dispatch. So there is a chain of activities and all of them are connected, and since everybody is connected, you know what's coming in, what's going out, so that the idle time is reduced. None of the resources will be wasted. Better customer satisfaction, obviously because things are being done faster, there is always a better customer satisfaction. Not only that, this entire concept of ERP can be used for maintaining a supply chain management. Supply chain management, you remember there is a supplier, then wherein there is a manufacturer, supplier to the manufacturer, and then connected to the customer. This link works pretty much well, and that is exactly what you need to take into consideration while dealing with this. And ERP can connect all these 3 people together, enhancing better customer satisfaction and improved supplier performance. Whenever you want, you can add or remove things, so thereby there is an improved flexibility. And since the kind of raw material that you procure, since the kind of activity that we do is all coming in at the right time and right place, we may follow concepts like just in time. We don't have to waste so much time on quality testing and also reduce the quality cost. Since you know what various departments are up to and how they are dealing with, better analysis, there is always a better analysis and planning. Improved information accuracy and decision making capabilities, while there is a use of the latest technology. So all these 12 being contributing to the benefits of the ERP system, you can keep upgrading the system to use the latest technology. So you know what ERP is all about. First of all, you know what are the 2 systems: integrated, non-integrated. Non-integrated systems are kind of outdated because no, you can use them, nothing wrong, but non-integrated systems, they don't really sound that great right now. So we are going for an integrated system, which is all about using a ERP. And since we are talking about using an ERP, we have to have a centralized database. Rather, you can even call it as a data warehouse. A short note on data warehouse. What is a data warehouse? Where the entire data is stored centrally in one place. It is stored centrally in one place. It's a complete repository. Data warehouse is a repository of an organization's electronically stored data. Also, data warehouses are designed to facilitate, reporting and analysis. We will see how that works, reporting and analysis part. Usually, this is a module that can be accessed by an organization's customers, suppliers and employees, so that everybody can feed in and upgrade and upload some kind of a data. So that is exactly what a data warehouse does. And whenever you want to see, there is a small process called ETL. Whenever you want to extract data, transform the data into meaningful form and load it back into the database for future use. It's called what process? ETL, extract, transform and load. We will talk about it again in data analytics. This means to retrieve and analyze data, to extract, transform and load data and manage the data dictionary. This word metadata means data dictionary, all the data in one place. Metadata is nothing but data about data. Data about data. That's what is metadata. So an expanded definition for data warehousing includes business intelligence tools to extract, transform and load data into the repository, and tools to manage metadata. We'll be seeing that's a small piece of definition that you need to understand, because ERP is now connected to the central data warehouse, because all the data that is there in the ERP will all be maintained there only. So you know what exactly the ERP is. So there is an ERP, which is an integrated system which is centrally connected to the data warehouse. Okay, this is a small piece of understanding that you want to have about ERP. Now let's get into the major part of this discussion again. Risk and controls, two topics wherein we did have to understand about what are the risks involved in ERP. This new concept has classification of risks into 5 different types. Let me show you the first one. First set, the risk in ERP they called as people risks. These risks are called what? People risks. Now when you talk about people risk talk about employees, management, the implementation team, ERP implementation team, everybody, anybody or vendors, they all play a very crucial role while dealing with ERP. So you should have a proper understanding of what they do and what they not. Also you need to understand what is the risk associated. The risk that is associated, the first thing is about change management, wherein it's not such an easy process to convert from the old system to the new ERP. So change has to be managed smoothly, transition has to happen smooth, and people should not leave the organization. You need to take care of that. And when you don't want people to run away from your organization because they don't want to work on the ERP, train them. Training. If proper training is not important, they will not know how to work on the ERP. It's a big risk. And then people may leave the job and go. Staff turnover. They may not be happy with what's going on in the new ERP, so they may leave and go. And you need to have proper top management support. It's not a one-day exercise, guys, this one. So it's a long-term exercise. It may take even a year or 2 years to implement the ERP completely. So you might as well want to take top management support and implement the consultants. And when you implement consultants, there's always a tension of third parties walking into the system. And when these kind of third parties walk into the system, there is always a risk that emerges. So yeah, that's the first risk, people risk. From all these people, these are the 5 risks that emerge, and what could be the risk, and against each of this there needs to be a proper control that has to be set up to make sure that you take care of people, don't leave your organization, people are well trained, all those has to be taken care. Then the next risk is about process risk, which I believe in the name only is there. If you automate a wrong process, or if you indulge an ERP into doing something wrong, then the entire thing can go for a toss. So which is why you have to be a little more careful in dealing with ERP. And what are the 2 process risks that we have? Management of programs, program management, that is one risk, where there could be a possibility of an information gap between the old system and new system. So you need to make sure that there is a smooth transition over, and all the processes defined clearly, because in the first chapter we talked about BPA. A wrong process, if automated, can make the entire thing go wrong. So if something is not connected properly, they are not linked properly, then the entire idea of ERP will be defeated. And then we have this ERP upgradation or ERP implementation is a activity of BPR. I hope you know what BPR is, a business process re-engineering. and we know how dangerous re-engineering could turn out to be, right? So it's important for you to understand how this works. The third category of risks in ERP is called technology risk. They're called what? Technology risks. Now, when you say technology risk, see, technology upgradation can be a risk, technology change can be a risk, software adaptability can be a risk. Let's look at some of the technological aspects. First one, software functionality. Software functionality. Sometimes, ERP systems can be over-engineered. Sometimes the ERP system can be over-engineered, too many functions. Sometimes the software may not work properly. So in such cases, we would probably have to take take this into consideration to make sure that it works more properly in this direction. Then technological obsolescence, technology becoming obsolete. Technological obsolescence means getting outdated. You know this. Enhancement and upgrades. If at the right time enhancement upgrades are not done, you may end up working on a outdated software, and for all this you have to always keep depending on the third party vendor, and it's not such an easy job to do that. And application portfolio management, this is not the only application that the entire organization will be using, so you need to take care of that. Application portfolio management, how many applications are there in your portfolio, what are those, how are they brought together, and how to work around them. Then let's talk about some of the next risk is all about other implementation risk, other implementational risks. The fourth category of risks are some of the other implementation risk. It's a long time to implement, lengthy implementation time, or long time to implement. Long time to implement the risks. So to avoid that, people need to be trained and put up them faster. Lack of funds. Lack of funds is other implementation risk. Timely funding not available. Data safety. Till now data were there with respective vendors. Now you will bring and put all the data in a central location, which can again contribute to a great risk. Data safety. See, in the initial days, ERP will work amazingly because data will be less and all that. But once the data from all departments start hitting the central server, speed of operations may come down, and system failure. If one part of the system fails, the entire organization will come to a standstill. That is quite a possibility. And just to make sure who gets access to master data and non-master data, data access, which is also another important risk. And then not only implementation, we talk about post implementation also. You have a couple of risks. Post implementation risk, who will take care of the system? Lifelong management. Lifelong management. All these are to be taken care of. So what you see right now on screen is a total topic of what are the various types of risks, and against each risk there are controls being specified for the working of a system and how exactly and smoothly they're supposed to work. What could be one of the best controls is called as a role-based access mechanism. Let me tell you what the short answer is. Role-based access controls are nothing but we will give you privileges or access privileges. Access privileges are given only on need to know. Access privileges are given only on need to know and need to do basis. Need to know and need to do basis. What is the work that they're up to, what is that they're doing, and how much work will they do? They will get only that much amount of the activity is totally oriented towards only giving them works that, access to only the work that they need to and they will be able to perform. That's what is called a role based access. And what are the accesses given to? You are giving access to create. Four types of access are there. Types of access. When anybody is given access, with how many types of access they'll be given? Create, alter, view, and print. Now, generally, all these four being given to one individual in an organization is the rare sight. If somebody is given like that, all four, then that fellow is called as a super user. Generally, super users or administrators are those people who have access to doing everything in the system. Like generally, what you right now saw there. So a role-based access, that is a short answer question that I want you to emphasize on. Be giving based only on their roles. You are a manager, so this powers for you. You are an assistant manager, so these powers for you. So something which is taking into consideration. Now also let us look at one of the most important topic in ERP, the 11 modules that are involved in ERP. I don't think I have to emphasize much on each of them, go by their name, but just let me quickly revise as to what are the 11 modules. First one is called a financing module. Financing module. Then the next one is called as controlling module. Now these two modules are undisputed parts of ERP because financing module talks about finance, controlling talks about cost and revenue elements. So almost all the modules which are either cost or revenue to the organization, they are somewhat connected to the these modules, the controlling module. These are called as integration. Key integration points. Who is connected to whom? Finance is connected to controlling module. Then the next module that we have is sales and distribution module, which deals with all the sales outward. Then we have a HR module or a human resource module. Then we have a production planning module or procurement module. This is production planning, which will talk about procuring the raw material, bringing the raw material in, sending the raw material out and all that. Then we have material management module. This is totally a inventory module. The material management module. Quality control module or simply quality module. That's a just to do the quality check and see for all the raw material that comes in, for the finished goods that go out, the quality management module or quality module, you can talk about it. And then there are a huge number of assets in factory, right? Which asset was serviced when, which asset is located where. This is all taken care by a module called as plant maintenance module. Plant maintenance module. And for individual projects exclusive, like say think of a company like L&T, they're working on multiple projects. Project wise they want to handle data. Then you have something called as project module. And then the last module is called the supply chain module, which is always a very important part of the module. And of course, there is one more called the customer relationship management module, the CRM module. And for exclusively the CRM module, we have 5 benefits. The 5 benefits, if you look up at what are the benefits of CRM module, it talks about better customer relation. Then you have improved time, that increases the revenues, reduces the time also. Then one more thing, increases, I want you to know these two terms, upselling and cross-selling. You know what upsell and cross-sell are? Selling a higher version of the same product to the existing customers is called upselling. While like say when you are selling a complementary product. Now I bought phones. I bought a phone, somebody is selling me the headphones, saying that these headphones work best with the phone. That is called cross-selling. I bought iPhone 7, then somebody is selling me iPhone 8. That's called upselling. One model up is called upselling and cross-selling. So you have better customers to deal with and do this upselling and cross-selling. And then you can have better internal coordination with the team, and also optimizing the marketing efforts, Now all these are some of the benefits of CRM. This could be a short answer question asked in the exam. Check out the 11 modules of ERP and then also this. And then you have what is called as key integration points. Means which modules of ERP are connected to what? They are called key integration points. When you say, let's say finance and controlling are connected. Okay, finance and HR are connected. Sales and material management are connected. Finance and sales are connected. So I'm saying etc. Like this, there are a lot of integration points. Which module is connected to what? And then plant maintenance module is connected to production planning module. Production planning module is connected to production planning module and material management module. and then sales module is connected to CRM module. This list is endless, guys. You can keep on writing, but just in case if they ask you in the exam what are the key integration points, just make sure to write which module is integrated with which other module. Now, like say HR module need not be integrated with sales module. HR module is one of the least integrated modules. So like that you can distinguish and decide which module does what, and you can go about it. So I think that's a lengthy discussion that we had on ERP. So let me quickly run through what we discussed here. ERP is a centralized system covering all the various aspects of the organization, finance, marketing, HR, all under one roof. That's what ERP does. The 12 benefits of the ERP system. What constitutes to using a data warehouse, and if you have to run everything smoothly, you need to have a data warehouse. And then we also talked about the wide topic of risks, and then what is a role-based access, what are the types of access, the modules involved in ERP, and the key integration aspects of ERP. I would like to take you through two more small topics that I would want to revise in this revision. Though ERP being the major topic here, I want you to also understand one small question. There is a question on MIS reports, the Management Information System reports. These are useful for management, for decision making. So if somebody asks you what is a report, report is anything that contains data which is helpful for making decisions. And what sort of information, type of information in MIS report? This is a short answer question that can ask. I can give you a shortcut that STAR means structured, timely, accurate, and relevant information is what we require when it comes to an MIS report. What is an MIS report? An MIS report is nothing but a report that presents all the data that is very much relevant for the top managers of the organization or mid-level managers of the organization to decision making. And what can come in the exam is the question, what type of data is used in MIS reports? The type of information that an MIS report gives is structured information, timely information, accurate and relevant information. Unless it has these four features, then only it makes sense. Otherwise, it's really not going to make any kind of sense using a MIS report. Okay, and let me take you through a very important short answer question on what happens with the data analytics. Now, very important concept. I hope you should take and brush up the basic concepts of data analytics, guys. So because I can't discuss the whole part here line by line, but then let me give you a quick insight about what data analytics is, and then we can go and see how data analytics works. So going by data analytics, I can tell you that it's a process. Data analytics is a process of examining not small amount of data, huge amount of data. Data analytics is a process of examining huge amounts of data or huge sets of data, you can say. Examining sets of data, small or huge, you can go by that. So what is data analytics? Process of examining huge set of data. Why? To draw conclusions. What sort of conclusions? Which are relevant for decision making again. So process of examining huge sets of data. Now you might want to pull out data from a data warehouse and then go about analyzing the trends and patterns. Now, as part of data analytics, there is another small concept that I want you to remind here is called data mining. So, data mining is a concept of extracting data from various data warehouses, and then you go by analyzing the trends and patterns, That's what we do in data analytics. Let me once again tell you what data analytics is. It's a process of examining huge sets of data. We gather all the set of data. Did I tell you the concept of ETL sometime back? That exactly is what is going to work in data analytics. Extract the data from various places, then transform the data into a meaningful form, and then load back the data into the system. That's how data analytics is, and that's what data analytics does. So gathering data from various places, these people are called data scientists. Nowadays, data analytics is the biggest thing going on around in the world. So gather data, put them into a meaningful form. That's what a data analyst does. And then once he is through with doing that, we will be able to see what a sort of data is ready. But that may not be used for all information. So that's why we work on it. We transform the data into doing something, and then uh, get that data in a particular order, load it back into the system for future decision making. Here, now you have two types of data analytics, guys. Data analytics. If this is what data analytics is examining and understand. See, two things. Are you examining and trying to understand information and go further with it? Or is it that you're trying to, confirm certain things? So, data analytics is about two things, EDA and CDA. First up, let's talk about EDA, exploratory data analytics. Exploratory data analysis is called EDA, whereas the other one is called confirmatory data analysis. Confirmatory data analysis. In EDA, you know what we're doing? We're exploring new data and finding new data and gathering data for our work. That's called exploratory data analytics. But when you look back at doing something and trying to understand if the data is really true or not, then that's what is called as confirmatory data analytics. So exploratory data analytics and confirmatory data analytics. What is data analytics? What is data mining? The two types of data analytics, and lots of tools are being used for doing all this nowadays. And now let's move on to discussing what happens inside data analytics. If somebody has already done this topic, you know that there are a sequence of steps. If you haven't, now you can mark them up. There is a set of steps that are being performed that goes inside the data analytics. So I'll give you those 8 steps as to what we do, and then if you can frame a proper answer using these 8 steps, you get all your marks. Very important short answer question as well. So first up, what is the first step that we will be able to do? It's more, see, data analytics is not just taking some data and analyzing that. It's much more than that. What do we do? Step 1 is about collecting. Step 1 is about collecting, integrating, and preparing data. Collecting, integrating, and preparing data. This is more like the E part of your ETL. Extract all the data, collect, integrate, and prepare the data. Then the next step after data collection is done, because see, if you don't collect and maintain accurate data, then the results that you get from that also will be useless. So first make sure that collect, integrate, and process the data, keep them in a understandable form. So then second step is, after collecting and preparing the data, testing and revising the data, so that all the loose ends, missing aspect, whatever are there, testing and revising the data. This is what is the second step. Now you have enough work to start with. But before beginning the analysis, first it starts with data collection, then all this testing, revising, and cleansing the data. This is called a data cleansing process. Okay, this one is called data cleansing, testing and revising the data and making sure that you get it. Then data from different sources. Data from different sources. Data from different sources are combined into one. Combined into one database. Central data warehouse. You combine on all, put up all the data. Data from different sources may be combined and loaded into, and then you know what you are supposed to do. Transform into a common format. Transform into common format. Okay, what did you do? First you gathered data, collecting, integrating, and preparing data from one source, and then testing and revising the data. One part of the data is there. Like that, from various sources you gather data and put it in one place, transform into one common format. Now ET part is over. Then we got to work on it and load it. But before putting that into that, transform it into a common format and put them into, once you fix. Now if there are any quality issues, fix data quality problems. Fix data quality problems, fix data quality issues. Once you're done with it, It makes sure that now your data is gathered from various places, transformed into one format, and quality problems are fixed. Then comes the most important step. Determine the analytical model. Determine the analytical model. What is this analytical model? Is nothing but maybe something like predictive modeling. You can use tools are there for this, predictive modeling tools or analytical tools, whatever. What sort of procedure are you going to apply on this data? Because that's not told anywhere, it's up to your choice. So determine the analytical model, predictive modeling, and then be ready with all the data. Now immediately don't do something on the whole data. So what you're supposed to do is to test on partial data. Test on partial data. Then after that you obtain results. Then after obtaining results you will check their validity. Now once you see that it's working completely on partial data and it's valid, then last step, step number 8, test on full data. And once you test on full data, this is done on a regular basis. So right now what you see on your screen is the 8th step. This is given in your module as a big paragraph. I think if you can identify these 8 words from that or 8 points from that, and when you are able to write the answer building or using these 8 points in the exam, that does a great deal of justification to the question, I believe. So you can take a screenshot of this, or if you are noting down while revising, you can always continue to use that while we do around with this. So we discussed about the master data, non-master data, definitions of system, process, and then we went on to understand front end, back end part of a software, installed applications, cloud applications, then the whole story about ERP, what is the MIS report, and what are the 4 types of information that should be there in MIS report, and the concept of data analytics, EDA, CDA, and then how it works in data analytics. Moving to the last part of this chapter, I'll just take you through again with a small insight on this concept called XBRL, where more of the work is there for you to do. What is XBRL? It is a reporting language. XBRL is a reporting language. So let me tell you how this XBRL works. XBRL works, like it has what is called as a taxonomy. Taxonomy is nothing but a dictionary of all terms available. So I'll tell you how this works, because broadly then you can sit and see how is it used and what it is used. I don't want to stretch this entire thing. So what happens is, like, say for example, you have financial statements prepared under Indian GAAP. Then you want this financial statements to be converted into some other country's GAAP, or there is a possibility that they may not understand. So what we do is, financial statement that is prepared in Indian GAAP will be converted in the XBRL format, because we have a dictionary of all the terms. What are the terms in iGAP called and what are those terms in XBRL called? We will convert into XBRL. Using XBRL, we can convert it into other GAAP, whatever you want. Or XBRL is a common platform, and the best part about this XBRL is it maintains documents in digital format, so that it can be shared across the world. Understood what is happening here? So in XBRL, if you ask me how this works, there is a dictionary of terms prepared by the XBRL, which is a consortium. It's a group, 600 plus members are already there. It's already there in 50 plus countries. India is also one of them. We also have XBRL reporting. So there is a concept called XBRL tagging, which is what I just told you now. What we do is take documents of local GAAP or in the local language, and then we find the exact equivalents in the respective language for them in the other one, using the taxonomy, which is the dictionary of terms, and what is the equivalent in the other language, we mark them up from here to here. That too we do it in digital format, but nowadays we don't have to sit and map it, because I, as an article student, I remember doing this kind of a mapping using huge bunch of Excel sheets and all that. But right now today we have some amazing softwares which can take care of this. 2 more questions as to who uses this XBRL. Who are the users? Government uses it. Regulators like SEBI, RBI, MCA, there are a lot of regulators, right? Those people also are using XBRL, and the companies for submitting documents to various people are using XBRL, and data analysts or data providers, data analysts or data providers, they are using XBRL. Investors from various nations, now like say I have a foreign investor, he doesn't know our language, of language in the sense of financial understanding, so they can use all this. And even companies including their accountants, chartered accountants, lot of people are using XBRL. And what's the best part about XBRL is that, you know, as part of this dictionary, everything is clearly defined. That's the first and best advantage. And whatever you are giving in ERP, the data from the ERP, when you transform it into XBRL and provide it, the regulators, for all these users, they can check whether the data submitted to regulators is correct. The companies can check before submitting. Regulators can check what is submitted to them is correct or not. They're called as testable business rules. So, is this compliant to this particular rule or not? The ERP, whatever data generates is converted into XBRL. Then the XBRL, what data we submit to the government, or government can also check using XBRL whether these data submitted by companies is correct or not. It's best part about XBRL, it's available in multilingual, that is it supports multi languages, multilingual, and software support from vendors. Software support from vendors is always available for the XBRL. So it's a great tool, guys. I think if some of you have worked on it, if you're doing articles and you've already worked on XBRL, you know what we're talking about. Tagging is the main aspect. So just go through the introduction of XBRL. What is it? Where did it originate from? What are those member nations who are following and all that? Then the concept of who uses it is very important, and the 4 advantages, and also know about the short answer called tagging, wherein you use a taxonomy to tag the terms in one particular format into their XBRL equivalents using the taxonomy, and then making sure that that particular thing is tagged into the respective XBRL format, and such digital documents can be transferred easily. So yeah, that's the end of chapter number 2. Again, if you feel that there is only an overview of the respective topics given, as I told you, this is just a revision, guys. So I want you to go back to your study and cover whatever we have discussed in the revision, and re-ensure and make sure that you're thorough with this particular chapter as well. So to conclude, once again, let me wind up this revision session by discussing the points. We discussed about master data, non-master data. We discussed about integrated, non-integrated systems, front and back end systems, installed and cloud-based applications. Those are first 4 topics. And then the whole concept of ERP. What is an ERP? What are the benefits of ERP? The risks involved in ERP across their controls, the 11 modules in ERP, and their key integration points. Of course, we also have to move and discuss from there as to what is the reporting system using MIS, and what is an MIS, and how data is reported using a MIS, and when a report is generated, what are the 4 types of information which is in the nature of star that can also be structured, timely, accurate, and relevant type of information should be produced from a MIS report. Then we discussed 2 short yet very simple and important concepts called data analytics and XBR. So I hope you liked the attempt of discussing this entire thing in 1 hour. Yeah, if so, I do understand that it might sometimes be a little fast, or if you have not attended something on a regular basis and then just want to do away things with this 1 hour video, I think it's slightly difficult task. But those of you who have done your rounds of preparation, I guess this is a great help to revise all your concepts.